Woohoo! Welcome back. Today we're going to be talking about solving basic equations. And what I'd like to start off with is the fact that the title of this section was given by the author. And I want to remind everyone, not that anyone could ever forget, but I do want to remind you that mathematicians live in a slightly different world than the rest of the humans. And yes, I do believe most math teachers are human, but I haven't met all of them, but I think most of them are, dark-hearted though they may be. And so the word basic should not be confused with the word easy. These problems are not intended to be easy. What the author is trying to express is that these are going to be the foundational techniques. These are the building blocks for the foundation so that we can take these, make sure everybody feels comfortable with these, and then run with it, because we will be expanding your understanding of solving equations using algebra. So this is not intended to shame anyone. And I do want to say that there are some of these equations which are really challenging. And so at any point, if you hit something in the lecture, in the homework, not making sense, definitely, see if you can work it out. Maybe take a break, come back to it. Sometimes it helps if you sleep on it, so you stop working, relax at night, because your life should not be 100% math, 90 to 95% math is fine. I joke, 85% is okay too. And, get some rest and then start fresh in the morning. On the other hand, there's some people who do better at night. So, if you're working in the morning and you're like, oh, I can't get this, wait till the evening. Let your brain kind of marinate on it. And if you still can't get it, please ask questions. Ask me, ask the tutors. In a perfect world, when you ask us, rather than saying, I don't understand equations at all, copy, take a screenshot, take a picture of the particular problem and say, this is the problem. Can we go over it? And then if that's not making sense, say, can you come up with some new ones? Let's practice some more. I can always come up with more problems. I've got 99 problems and all of them are math. Plus I got some other problems too. So let's go forward. I brought out my friend, Yoga Skeleton. And the reason that I like Yoga Skeleton for solving equations is because Yoga Skeleton, let me get them kind of straight up and down. Yoga Skeleton is interested in balance, interested in left and right balance. And so that's going to be the key word, is that whatever we do to an equation, we need to work on both sides so that we keep a stream of what are called equivalent equations. Now, at this point, if you are in this class, you've probably had a couple years of algebra already. So you've got a ton of solving equations practice. And so rather than go over everything you already know, I actually thought I would approach it in a way that I've never seen before. And this is my first draft. I'm very proud of it, but there will probably be more drafts after this. So I apologize if it's it's brand new and shiny, but probably can use some updating. But basically, I just wrote out all of the different techniques that I could think of that will be useful in this class for solving equations. For example, you can add something to each side. You need to add the same thing, of course. You can do this in any equation. Are there any problems? No. When you add something to both sides, no problems. As long as you're adding the same thing to both sides, you're good. Same thing with subtracting from each side. You can do that with any equation. There's a none here, although I'm going to tell you, those of you who are headed to a study of math, you will discover subtracting from each side doesn't exist. It's all considered adding. You add positive numbers or you add negative numbers. You don't consider subtraction at all. And that's just one of the cool, fun facts you can learn taking math. Ooh, very exciting. We get rid of subtraction entirely. It's super cool. Okay, multiplying both sides, you'll see that all of a sudden it gets really big. The possible problems is just full of stuff. Let's look at it. So when you multiply both sides, usually what you're doing is you're clearing fractions. That's usually the goal. And so if anyone ever says clear fractions first, or even decimals, that's what you're doing. You're multiplying on both sides. So you can do this with any equation, but you're especially going to use it with equations that have fractions or something is in the denominator, maybe even a variable. So if you multiply by a constant, a number, you multiply both sides by 5, no problem. Do not multiply both sides by 0, even accidentally. So do not multiply both sides by 0, actually 0. And do not multiply, this is what this says, if you're multiplying by a variable or a variable expression, make sure that expression doesn't equal 0. And so we're going to talk about that with when we actually get to practicing, that's going to be talking about restrictions on the variable. We'll get to that in a little bit. And the thing is, you can create extraneous solutions when you start multiplying by variables. So things get interesting. And always check your answers. Okay, dividing both sides. Pretty much you can do that any equation. Same thing. If you're dividing by a number, both sides by 5, you're golden. But if you start dividing by things that are variables or an expression with variables in it, then you could create extraneous solutions. Always check your answers. You might see that there's a theme here. Okay, let's come down here. The quadratic formula. I'm just reminding you what these things are. So this is a list of all the different techniques. You can use the quadratic formula anytime you have a quadratic equation or an equation that reduces to a quadratic equation, which you may have experienced before and you may not have. So, we can always talk about that. Generally speaking, the quadratic formula, if it is truly a quadratic equation, the quadratic formula doesn't have any problems. If it's another equation that looks like it's quadratic but not quite, like x to the 4th instead of x squared, then you might get some interesting results. But what's the answer? Always check your answers. You notice the theme? Yep, I know. Squaring both sides. Okay, now we're getting into some really interesting details. You can square both sides if you have radicals, right? You got square roots running around, you can square both sides. You want to do that very carefully because it makes a mess of everything. Plus, it often creates extraneous solutions. If you square both sides, it's chaos. Not quite. It's not really chaos, but it's a lot. So always check your answers. Taking the square root of both sides, also a little dicey if you have a quadratic equation. Now, when you take the square root of both sides, make sure you're actually able to. You're not taking the square root of something negative and ending up with an imaginary number, unless you're allowed to have an imaginary answer, in which case, go for it. So again, check your answers. But there's an interesting, this one is one of the few. When you take the square root of both sides, make sure you put a plus or a minus, because you have to account for the fact that sometimes the answer might be positive or negative. Once you've squared it, you wouldn't know. So when you square root, you got to stick that plus or minus back in. That information got lost. But again, that is going to create extraneous solutions. Check your answers. Taking the cube root of both sides for a cubic equation. Now, I'm going to say something that if you're at the beginning of Math 90, will just be a, what? But it'll make sense later on. And the answer is, if you take the cube root of both sides, you're only going to get one real solution. You are going to miss the other two solutions. Yes, I'm saying that cubic equations have 3 answers. So we're going to have other techniques later on that'll show you how to deal with this. Always check your answers. Raising both sides to a fractional power. Now, this is the one that you may not have experienced before. I'll show you. It's pretty straightforward. This is something that the book calls power equations, which sounds very exciting. Ooh, power equations. I would say, what am I going to say? Extraneous solutions. Check your answers. You can see I'm pretty much a broken record. A record is like a CD. A CD is like an iPod that's flat and round like a pizza. That makes perfect sense. There we go. Factoring using the zero property. We use this with polynomial equations, but there are no possible side effects that I can think of, but be careful with the sign change. So if you end up with one of the factors is x minus 4 and you set it equal to 0, remember that x is not negative 4, x is positive 4. So it's always the opposite of what. So if a minus 4 shows up there, the answer is going to be positive 4 and vice versa. And always check your answers. So the moral of the story is always check your answers. Why? Well, even if you don't make any mistakes, the way that we've set up some of these techniques, we are actually changing the equation enough that when you solve the new version of the equation, you get a couple of answers that may not completely fit the old equation. Why do we do this? Because it's our best choice. Sometimes we don't have a choice. Sometimes we have to go with that, squaring both sides or doing something else, and all those shenanigans, they're going to bring in some error. And we do our best to check to make sure we can find any error that creeps in and get rid of it. So extraneous solutions. Are you guys ready for solving? Oh my gosh, I am. Woohoo! Linear equations and equations that reduce to linear equations. So basically, what's a linear equation? That is, if it's got a bunch of x's, nothing else, it's linear. Now this has a bunch of x's. This one is technically not linear the way that it's written, and that's because x is in the denominator. So to be linear, you have to have x not in the denominator. You have to have x not squared. So no x squareds, no square root of x, nothing but numbers and x, and that's linear. It's just really nice. And it means that it describes in, when you're graphing, if you introduce a y, it'll describe a line, which is really nice. So linear, kind of like lines. Okay, let's go ahead and solve number 1. Number 1 is the first type of equation you would have learned about in your very first algebra class. And so basically what we're going to do, the way I solve it, and again, you guys have your own way of solving it, so go with it. Some of you love the left side. X always goes on the left. That's the rule. There's no other rule. Awesome. You rock on. I am a little bit lazier and I say, okay, I'm going to look at negative 5x, positive 4x. Technically, this is larger. And again, we're going to be talking about this larger and smaller issue. A negative 5, because it's negative, is smaller technically than positive 4, even though 5 is bigger than 4. So I'm going to go ahead and move all the x's onto the right. If you don't like this, then don't do it that way. Do it your way. There are lots of ways to do this. So to move the x's, I can't actually move the x's. What I'm allowed to do is I'm allowed to add 5x to both sides, right? Balance. Our friend Yoga Skeleton says balance. Same thing left and right. So I get 2 equals 6 plus 9x. Woohoo! Next thing, my goal is to isolate x, get it by itself. So the x's are over here. Let's move the 6. Subtract 6 from both sides. I get, I think, negative 4 equals 9x. I'm not thrilled. This is not the most fun I've ever had doing math, because I'm looking ahead going, ugh, I'm going to end up with a fraction, but I'm going to end up with an answer, and an answer is good. So to isolate x, I'm going to divide by 9, both sides. This is a non-zero constant, so this is not going to be a problem. And then I just flip this around. And again, if you're the person who likes to work on the left, work on the left. You don't have to flip anything around. You will get the same answer. Okay, so what did I say was the rule? Always check your answers. Woohoo! So I'm going to go ahead and check. And that means I need to check in the original equation. 2 minus 5 times negative 4/9. I'm not thrilled about this, right? Now my question is that equal to 6 plus 4 times negative 4/9? Okay, so I've got 2, and then I'm going to multiply, so I get plus 20 ninths over on the left. Remember, 5 is 5 over 1. 2 negatives multiplied together is a positive. Then I'm going to have to combine these. So either I have to write this as a mixed number or as a fraction. It's up to you. However you want to do it. I'm going to do it as an improper fraction. So 2 I know is 18 ninths plus 20 ninths is 38 ninths. Ooh, isn't that beautiful? Okay, over here on the right. Oh, and I should stop and say, no shame. No shame in your game if you don't know how to get from 2 to 18 ninths. I'm not going to take the time to explain it right now, but I will say, come talk to me. Go talk to the tutor. Say, I don't know how to get from 2 to 18 ninths, and we will show you. We will make sure you know how to do it. The good news and the bad news, well, let's start with the bad news. The bad news is calculus is built out of fractions. The good news is you're going to get lots of practice with fractions. So by the time you get to calculus, you will be ready for it. But fractions are the name of the game, so you want to keep practicing. And anytime you want help, come talk to me, go talk to the tutors. We'd be overjoyed to help you, really. It is literally, that is our job. That's it. Okay, and making cute puppets. That's, that's part of my job. I'm going to put our skeleton friend over there, so I've got room. Over here, let's see, I've got 4 times negative 4 over 9. That's 6 minus 16 ninths. 6 is going to be 54 ninths minus 16 ninths. So I get 38 ninths. Oh my goodness, they're equal. And I put a check mark next to it. Whenever you're checking, separate it from the rest of your work. Write the word check because that helps. That helps whoever's grading your paper. It's a really kind thing to do. Okay, let's move on. So that's a linear equation. This next one, oh my goodness, this next one says it's number 1. What? It's not number 1, it's number 2. Ah, heads will roll. Right, skeleton? Yes. We are going to have to, I don't know, some assistant wrote that and got it wrong. Can't believe it. Someone would not know the next number was 2. What were they thinking? Okay, so I have x's in the denominator. It is, in fact, possible to solve this without moving the x's out of the denominator, but I really don't recommend it. However, if you know how to do it, go for it. Again, rock on. There are a lot of different techniques that we never explain. If you've come up with some interesting ones, you might want to run them by me so I can let you know whether they'll work in general, because, some of them seem like a good idea, but maybe have some down, there might be some pitfalls for some of them. But I'm going to go ahead with the more standard way of dealing with this, which is anytime you encounter fractions, multiply by the denominator. So I'm going to multiply everybody by x. So for the fraction, I'm going to write x in its fractional form, x over 1. And for the whole numbers, I'm going to write x as just x. Oops, already with the whiteout. Ugh. So a lot of people ask, why don't you do math in pencil? And the answer is, I'm not really sure, but I think where I started doing it was 2 reasons. One, my teacher said, never, never do math in pen, and immediately that was the only thing I wanted to do. That was my heart's desire right there, was to write it out in pen and be like, ha-ha. And the second thing is I actually am, I have a little trouble seeing, and I think it's just that pen is easier to see. It's a higher contrast. Pencil is kind of shiny, in that graphite way. It's a very light color and it's shiny and it's really hard to see. So I personally like pen. If you like pencil, go for it. If you like pen, hey, make friends with your local tape whiteout thing. Okay, so let me bring out the red pen of destiny. Woohoo! And let's start cancel Rama. Here we go. We're going to get rid of that x, woohoo! If you want, sometimes when dealing with fractions, the best thing is to make exploding noises, like they're crumbling down. if you want. You don't have to. I mean, I don't know anyone who does. I certainly wouldn't enjoy destroying fractions. What? Okay. So, and then the nice thing is you can see, even though this problem looks really yucky, it turns out to be this problem, which you might notice is this problem. Look at that. Oh my gosh. Oh my gosh. What are the chances that I wrote the same problem twice? I mean, 100%, because I did it exactly for this example. But so I want to point out it's not always obvious from the first form what you're going to end up with. So you don't always see things. But once you see things, this is the problem from number 1. I wonder if subconsciously I labeled them both 1 because they were the same problem. That's an interesting one. So what are the solutions? The solution is x equals -4/9. So if you ever come across a problem that's identical, you don't have to solve it a second time. I'm not saying go through it again. If the problem is identical, then you already know the answer and we don't have to see above. That's all you need to do. Woohoo. Okay. So far, so good. Here we go. Let's do one more. Dun, dun, dun! I know, it's one of those times when I'm not showing you the problem because I'm giving you a chance to breathe. So go to your happy place. Imagine puppies, or if you don't like puppies, imagine whatever it is you do like. You know, you're sitting by a stream, or you're sitting somewhere where there isn't any math, or maybe you're sitting right next to this problem because this is your happy place because you can totally rock this. Okay, this is a mess, and it would be very fair to say, hey, this doesn't look linear at all, because it doesn't. It isn't linear. However, it has a trick. Dun, dun, dun! So, whenever you've got denominators, hopefully someone convinced you that the best thing to do is to at least factor them if they're complicated. So I've got 1 over x plus 3 plus 5 over some mess equals 2 over x minus 3. Now, x plus 3 and x minus 3 are already fully factored expressions. They are linear. But x squared minus 9 is a difference of 2 squares. Right? It's a difference of squares. So it factors as x plus 3, x minus 3. And at this point, I'm actually going, since there's a lot of gobbledygook stuff in there, I have to come up with the LCD. Some people use LCM. You are welcome to use whichever one. LCD stands for least common denominator, or lowest common denominator. And LCM is least common multiple or lowest common multiple. You can look at it either way. I don't have a preference. I think LCD is most common, so I use it. That's the only reason. And basically, what we've got is we've got x plus 3, we've got x plus 3, x minus 3, and x minus 3. And all together, we need one expression that will cancel everything. So, the rule about finding a least common denominator is that you look for the most times something appears in any one expression. So in other words, I've got an x plus 3 and I've got an x plus 3. Do I need both of them? And the answer is, if I look at each of these fractions, I'm going to try to clear fractions by multiplying. I need 1x plus 3 to clear this. And then this is a separate expression. I need 1x plus 3 here. I don't need any x plus 3's, but I'm going to get one. So I only need 1x plus 3. And for the same reason, I only need 1x minus 3. The only time you would need more than that is if this were x plus 3 squared. Then I'd need 2 of them. So I'm going to take this, and I'm going to multiply everybody by that. And, oh, you know what? I don't want to start with red, sorry. Oh no. Sometimes my whiteout is like, why couldn't I work for, like, you know, the English department? Why does it always have to be math? Okay. I think it's probably perfectly reasonable and normal to think about, the dreams that your inanimate objects have of what they want to be when they grow up, right? That's totally reasonable and normal. Okay. And what is also perfectly reasonable and normal, and you'll see I do it. Look at me writing big, taking all the space, and then realizing, oh no, I've run out of room. Okay. So you'll notice that most of the time I print my notes out for my videos out on plain paper. The reason for this is that it's easier to print on the plain paper and it makes it very visible. To be honest, to help with the spacing, I would encourage you to work with grid paper, whenever possible. If it helps, if you hate grid paper, then it's not helping, so don't use it. Okay, so red pen of destiny. I use red because it's visible, and I use a different color so that it doesn't just look like something like scratching itself out. You can actually distinguish the different parts. So the x plus 3 cancels out here. The x plus 3 cancels out here, but so does an x minus 3. Yay! You can make the exploding noises. X minus 3 cancels there. Let's figure out what's left. I've got an x minus 3 times 1, so that's good. I've got a bunch of 1s and a 5. Woohoo. And then over here, I've got, it looks like an x plus 3 and a 2. So far, so good. So over on the left, x minus 3 plus 5 and 2x plus 6, I think, right there. Okay. So far, so good. Let's see. X plus 2, 2x plus 6. I've got more x's on the right-hand side, and I'm going to subtract x from both sides, and I get 2 equals x plus 6. And so I think you can't see it. Sorry about that. I think the answer is x equals -4. Woohoo. And I'm also realizing that I skipped a step at the beginning. So I'm going to take a moment here, let everyone take a look at that. Ask Yoga Skeleton why they didn't help me. They're just very quiet. They're not interacting with me right now. Oh well. So they did not remind me. Perhaps you caught what I did not do. And the answer is yes, I have to check. Absolutely. So we will check on the back or on the next page. But what didn't I do at the beginning? What's really important when we do a problem like this, which I'm always like, you have to do this. You have to do it to my students. And then they're like, ha, you forgot. And the answer is, I did. But the great thing about writing things out is no one knows if you do it at the end rather than at the beginning because you forgot. So there's a word up here I should have used. Restrictions. So what are the restrictions? Well, the restrictions are x can't be something that's going to make it, the whole expression, have a 0 in the denominator. So what would make this be 0 in the denominator? You got it, a -3. So x cannot be -3 at all. That'll just blow this one up. And then what about this one? X can't be -3, but also x cannot be +3. You got it. And then for this guy, yeah, x can't be +3. So whatever we do, we do not know what happens. When x equals -3 or x equals 3, we end up with 0 in the denominator, which means we don't know what to do. And hopefully a previous teacher told you if x were -3 or +3, we would end up with something that's undefined. And undefined means we haven't been told what that is. And spoilers, you will learn more about this, but it takes a long time. You learn about it much later on in math. You spend a lot of time looking at it. For right now, basically, it makes the whole thing get really, really, really big or small, and we don't really have the tools to work with it. So we just say, you know what, we're just not going to go there. Those are not going to be values we're going to try out. So let's go down here. Did we have trouble with the restrictions? No. In fact, we got x equals -4. So, oh, I'm very excited. Are you guys very excited? Shall we check? And of course, what I should do is, because this one's marked as 2, it was actually number 3. So I'll fix that. And then I will do the check for 3 up there. And again, horrible as it sounds, we have to check the original. 1 over x plus 3 plus 5 over x squared minus 9 equals 2 over x minus 3. Okay, why do we have to check the original? Well, because at any point after this first line that was typed, not by, well, it was typed by me, but it was on the paper, everything I did here from the very beginning, I might have already made a mistake. So I got to start with the very first thing to make sure I'm catching all the mistakes. So we're going to check x equals -4. And I know everyone's thinking, oh no. And the answer is it's okay. And also the answer is you might see that there are a lot of fractions in this class because we are getting you ready for fraction Rama of calculus. So, and those of you not going on to calculus, you're going to miss all the fractions. I mean, why do that? Just take calculus for fun. Totally could happen. I took Shakespeare for fun. It's kind of like the same thing. It was actually really fun. Squared minus 9, 2 over -4 minus 3. And so the way I check is I put a question mark that helps me remember, do not cross the streams. You have to do the left side and the right side separately, like the McDLT. Look that up. Jason Alexander McDLT commercial. I will try to remember to put a link in for that. Okay, so I have got right here, I've got 1 over -1 plus 5 over, remember -4, the quantity squared is 16, positive 16. Okay, so this is -1 plus 5 over 7. Oh, that's beautiful, isn't it? So this becomes -7 sevenths plus 5 sevenths is -2 sevenths. Remember that for an answer to check, what you get on the left does not have to match the answer. It just has to match the right. Okay, so over here, it's going to be a little bit easier. Some people like to draw a line to remind themselves, do not cross the streams. But this isn't going to take us a long time because -4 minus 3 is -7. Oh my goodness! They're equal. It checks. A minus out in front is equivalent to a minus down the bottom. They're equal. You get the same result. We did it. I mean, I did it, but you did it with me. And you kept the faith, and there were a lot of fractions. We made it through. You made it through all the talking in the beginning and some silly jokes. You guys are awesome. Congratulations. Next up, we're going to be working with solving other kinds of equations. So, stop this video or let it run out. Take a break, go look at something green, get some snack, get some hydration, maybe a nap, maybe make some art, or go write some stories, or, make some music, or I don't know what people do. Mathematicians don't know what other people do. All I know is I sit inside and make videos all the time. So, do whatever it is that humans actually do with their spare time. Maybe Pokemon Go, right? Go Red. What? I didn't say that. Anyway, so you guys are awesome. And I'll see you back in the next video. We'll talk some more about some equations. It's going to be super fun. And math on.